This is the introduction to mole conversions. I'm hoping by now you've seen the video that I posted from YouTube. Obviously it wasn't me, it's someone else who explains it pretty good, Mr. Post. I think he does a nice job. I don't know him personally, but let's take a look at some of the practice things we can do for this. So take a look at number one. What we're looking for is the total mass of 1 mole of NaOH. So to get the total mass, I have 1 Na, 1 O, and 1 H. So the subscripts are the ones that come first. So this right here are the subscripts. Okay, I multiply that then by the atomic mass. Now I'm rounding off the atomic mass. If you take a look on a periodic table like the one that I have attached to this assignment, you will see that in this cell for Na, it will have something that looks like this, and it will say 22.9987. Doesn't matter what it says, but it says 22.99 something. I'm going to the 10th place, which means I'm rounding up to 23.0. Okay, so once I get to 23.0, I multiply that by 1. Obviously, I get 23.0 from that. Oxygen, if you look on the periodic table, the atomic mass of that is 16, so I got 16 like this, and hydrogen is 1.0. Some of these, like oxygen and hydrogen, you will start to remember just because you use them so often, because they show up in just about every compound. So what I do then is simply add them up as I go down, and I get 40 like this. That is the number of grams in 1 mole of excuse me, sodium hydroxide. 40 grams per mole. Okay, so let me get rid of some of this stuff here. We can do some of these, like this will go much quicker now that you've seen how to do it. The 2 and the 1. Notice that there's a 1 there, but we don't write 1, so if you don't see anything, it's a 1. That's 1.0, so that's 2.0. There we go, 2 times 1.0, and 1 times 16 gives you 16. That's how we get 18 grams per mole. So remember, we're multiplying subscript times atomic mass. This number right here is the atomic mass. There we go. Of each of the atoms, or each of the elements. So one more, let's take a look at one that's just a little bit more complicated. Let's take a look at number 6. So here for number 6, I have N, I have H, I have S, and I have O. Okay? So subscripts for this. Now the 2 on the outside of a parentheses means I multiply everything inside the parentheses by what's outside the parentheses. So normally I would have 1 N and 4 H's. That's what the no number there for the N and the 4 for the H means. But since there's a 2, that means my subscripts turn to, there we go, 2 and 8. There's a 1 for S and there's a 4 for oxygen, like that. So then I go to the periodic table and I simply write down what the atomic mass is of nitrogen, and it's 14.0. So 2 times 14 is 28.0. Like that. 8 times 1.0 gives me 8.0. And 1 times, now for sulfur, it's 32.066, whatever it is. I round it off to the hundreds place, excuse me. So 1 times 32.1 is 32.1, and 16 times 4 is 64. And then I add all of those up. I get 40, 68, and 64 is 132.0, and that is grams per mole. If you want to see where I'm getting the atomic masses, this is the periodic table on the bottom. I happen to know the atomic masses because I've done this for so long, but here you can see sodium, atomic mass for that, atomic mass for nitrogen, for hydrogen, for sulfur. Okay, so I'm rounding all of those off to the 10th place, just the 10th place. So that's how I do all of that. So take a couple of finish those up 1 through 6. I did 3 examples for you, so you got 3 more to do. Let's take a look at some more examples of calculations. So here's the 3 conversions you really need to know. This one, just like it says, we will hold off until later on. And I say 1 mole equals 6.02 times 10 to the 23rd particles. If you've watched the video, you know that 1 mole is just accounting like it's like a dozen. 1 dozen equals 12. 1 mole equals this incredibly large number. And he explains like how big that number is. Now that number of atoms of carbon has a mass. So 1 mole of carbon atoms equals this number of atoms, and their mass is 12.0 grams on the scale. Okay, so that's why we do all the business with the moles, because it kind of levels the playing field, so to speak. So we can compare one type of element to another. So we know a mole has that number of particles. We know a mole is the molar mass of that number of particles. 1 mole also, if we have a gas state at a certain condition, standard temperature and pressure is, and you don't need to know this right now, but the temperature for this is 273 Kelvin, which is freezing point of water, and the pressure is 1 atmosphere, which is approximately what you're feeling right now. So, excuse me. We do something called, they call it dimensional analysis, they call it factor label. It all amounts to the same thing. Whenever we do a conversion, we take 1 mole over, and then whatever the molar mass is that we've either added up for a compound like we did in the previous steps, or it's directly the mass, atomic mass right from the periodic table if we have an element. So we have 2 choices here. We can go 1 mole over molar mass in grams, or molar mass in grams over 1 mole, depending on what we're solving for. So let's show you some examples of that. I'll show you how to do that right now. So how many moles are in 15 grams of lithium? This is a great question. So how many moles are in 15 grams of lithium? Well, first thing I do is start off with 15 grams of lithium, like this. I put it over 1 to make a fraction out of it. Now, I'm either going to put 1 mole on top or 1 mole on the bottom. Whatever I do, if I put 1 mole on top, the reason why I did that is because I know that the mass of the atomic mass of lithium, since we just have 1 element here and not a compound, excuse me, is for lithium, it's 6.9 grams. As long as we get grams on top, right here, and then on the bottom, which is why I put grams on the bottom here and 1 mole on top, they cancel like this. I take 15 divided by 6.9, so you divide when the number's on the bottom, and then, where's my calculator at? And then I round off. 15 divided by 6.9 equals, I get 2.1739. We haven't done this kind of stuff in a long time. This is the number of moles of lithium, because that's what we have left. The grams have been canceled, okay, which is the whole reason why we do this, so we know we can cancel the grams and we're left with moles like that. So we round off. We have 15 is 1, 2 significant figures, so 1, 2, that's 5 or higher, so my answer should be 2.2 moles of lithium. I hope you remember how to do all the rounding stuff. So let me get rid of some of this stuff here, like that, and take a look at the next one. So how many grams are 2.4 moles of sulfur? So the first thing I do is put whatever number I have with the units on top, like that, over 1. Now I look on the periodic table. If you remember from the first part where we did sulfur, is 32.1 grams per 1 mole. So in this case here, I'm going to put 1 mole on the bottom. The reason why I do that is so that moles of sulfur cancel with moles of sulfur. We're left with the atomic mass of sulfur at 32.1 grams, like that. And now the number other than 1 is on top, so I multiply. 2.4 times 32. And I get 77.04 grams of sulfur but because I only have 2 significant figures here, I just shorten it to 77 grams of sulfur, and that's my answer. One more. I'm going to do one more set of examples, so hang on. Now we're no longer doing just a single element. Now we have a compound. What is sodium fluoride? It's NF. So that means that if I want 1 mole of sodium fluoride, I do this business here, 22, that's going to be 23.0. And fluorine is 19.0. This is the atomic mass of sodium and fluorine. Check it out on the periodic table. You can see that if you round off to the tenths place, you get the same thing I do. So that's 23 plus 19, like this, and I end up with 42 grams per mole. Oops. Come on. There we go. Like that. So let's start the problem now. So now I got 4.5 moles of sodium fluoride over 1. Always put the number that we start with the units over 1. And then, do I want 1 mole on top or 1 mole on the bottom? If you said 1 mole on the bottom, like this, you were correct, so that we can cancel moles and moles, like that. And then the amount of mass of 1 mole of sodium fluoride goes on top. And then 4.5 times 42.0. 4.5 times 42.0. And I get 189 grams of sodium fluoride. 2 places. Check to see if it's 5 or higher. It is, so this would be 190 grams of sodium fluoride. Okay, that's how we do that. Now we got another problem just like this. This is aluminum hydroxide. So aluminum is Al, hydroxide is O, and H. I have, if you notice, I have 1, I have 3, and 3. Those are the subscripts for the formula of AlOH3. So I multiply by, 27.0. Check it out on the periodic table. This one is definitely 16.0, and this one is 1.0. Okay, so as we go through here, I get 27.0. 3 times 16 is 48, and 3 times 1 is 3. Like that. And I add all of that up. So what is that? That's 30 plus 48. Looks like it's 78 grams per mole. And then I get 98.3 grams of aluminum hydroxide. I got that from the start of the problem right here. That all goes over 1. So what goes on top, what goes on the bottom? If I have grams right here on top, then I need my grams right here on the bottom of aluminum hydroxide. Okay, this is easy, the easy stuff. So 1 mole of aluminum hydroxide goes, there we go, on the top. The number of grams goes on the bottom. I divide the two, 98.3 divided by 78 grams equals, and then that is 1.26025. Don't just keep writing numbers down. We round off to 1, 2, 3 places. So 3 places gives me 1, 2, 3 like that. So 1.26 moles of AlOH3 like that. Okay. Good luck. Finish that up. You're responsible for all the rest of the numbers that I did not do. And I'll check it out on your submission and leave you a note to let you know how you're doing, to see if you're doing well. Okay? Thank you for paying attention.